All right, guys, we are in the book for the fundamental theorem of calculus. So this is one of the major things about integrals, and it's basically kind of a relationship. If you want to look more about it and talk about the antiderivative part, it goes into a lot, and it's kind of it's a really like deep concept, but it's basically the ultimate of the relationship. So like this is an integral. So the idea, this is an integral. So the idea is what happens when we take the derivative of the integral. And so it's this theorem that says as long as this is a constant, the derivative of this integral is f of x, with x being whatever is up here in the function itself. So like if you take something like this is a constant because it's pi, so it's a constant. So what we say is this. If I take the derivative of this, then it's just equal to, and actually this is a different looking one. It is literally f of x, the function of cosine. So it's the cosine of x. That's the answer. So when you're finding the derivative of this integral, and this is a constant, it is the function of what you have here with the x in its spot. So if we go to this next piece, normally this would be cosine of x, but this poses a large problem for us. It doesn't pose a large problem for us. It just means that it's a composite function, or there's more things that need to be done. So the idea is that if I'm taking the derivative of this, well, that means if this x squared goes in here, I've got to account for it somehow, so we've got to take the derivative of this also, because I still have my constant. So this is going to equal, so you can imagine like this is u. U is x squared, right? So let's take that out. So now we have this piece here. So we get the cosine of u, correct? But now I've got to deal with du still, so this is 2x. So this will be 2x cosine of x squared. So it's the same idea, except we got to account for this derivative here. So that is my answer. That is f of x. Okay? So as we walk our way through those are the kind of the small little pieces we got to watch out for, is that if it's not just a straight x, and this is a constant, we got to assume that this is a u. So then we have to account for the fact that it's u, and we have to deal with u substitution and a power rule, and it's a composite function at that point, okay? Because look, composite function, there's two of them. That's why this is x squared. It's a composite function. That's where it came from. So we're really undoing our integral by taking the derivative of it. All right, so now we go to this one here. Cool, constant's not here. Don't forget, we can manipulate these things. So we can say, oh, well, d of dx is, because I need the constant here, is from 5 to x, and that just changes the sign. 3t, so that should be a t right here, sine of t dt. Whoops, dt. So now we go, oh, okay, well, I've got this piece, so by the fundamental theorem of calculus, now I've got what I need. I got my constant here, so that means the derivative of this thing is the function of x. And that's my answer there. Okay? So when you switch the order of these, you just change the sign. You're just switching the order, so it tackles it for us. All right, so now I've got one more special case to show you guys, and this stuff's out of the book. So that's when they mess with your guys' brains, and they do stuff like this. They say, oh, the integral from x squared, from 2x to x squared, and they do 1 over 2 plus e to the x, sorry, e to the t dt. Dt. And they go, oh yeah, you know what? Let's use the fundamental theorem of algebra. Of calculus. No constant. What do we do at that point? Well, remember that this can be broken up into two pieces. You have an upper boundary and a lower boundary. So technically, you can do this and say, I'm going to go from 0 to x squared, because we don't know where it's at, right? There's my constant of 1 over 2 plus et dt, minus upper boundary, lower boundary, minus from 0 to 2x of 1, 2 plus et dt. Now all of a sudden I've got my constants where I want them. Okay? I still have to worry about this one right here because it's a composite function, so I know I got to deal with du. So then if I take this idea, this one, and this is a negative because we also flipped, it went from 0 and it flipped up. So now we've got this idea that we can deal with this. So we can do the derivative of this, which is going to be 2x to account for this, times 1, 2 plus e to the x, minus 1, 2 plus e to the 2x. And then we can tackle this algebra and finish the problem up. So when you're given two variables or two composite functions or however you want to look at it, you can split them in two because we're going from 0 to x squared and then we're going from 0 to 2x. So that allows us to come up with the fact that we need a constant here. All right, guys, so you're going 1 through 19. I forgot what page it's on. I can look right here. It's page 310, I think. 310. But that's how you're going to tackle these. There's 3 different ways, the ones that we just showed you there. And we'll talk about it more on Tuesday. Good luck.